Today we're going to look at chain rule or anti-chain rule, undoing the chain rule. So first, let's review the chain rule. So how do we take the derivative when there's something on the inside? We have the peanut inside the peanut M&M. Well, when we take the derivative, we take the derivative of the outside first, eat the chocolate. So the derivative of sine would be cosine. Then we eat the peanut. We take the derivative of what's inside, so times the derivative of 3x, which is a 3. So we end up getting f prime of x equals 3 times the cosine of 3x. So if I were taking the integral of this, hold on, let me just go through and let's just review the chain rule first. Okay. So in this one, the peanut is cosine x, so to take the derivative, e to the power would just be e to the power, and the derivative of cosine is negative sine x. And usually that would probably be written as negative sine x times e to the cosine x. Okay. The derivative of this one would be chain rule. We do power rule first. 4 times 2x squared plus 3 to the third power times the derivative of the inside, which would be 4x. Now when this one gets simplified, that derivative of the peanut gets kind of hidden with the 4. And you'll see what I mean by hidden in a second. So the derivative of this one, let's rewrite it first. That would be x squared plus 3 to the 1/2. So that would be 1/2 x squared plus 3 to the negative 1/2 times the peanut times 2x. So when this one gets simplified, it would be, well, the 2's would cancel. I'd have x over the square root of x squared plus 3. So when I go to take the integral of that derivative, some of these can be done by what is called pattern recognition. We know when we take the derivative of a composite, of a chain rule, we would take the derivative of the outside, leave the inside unchanged, then multiply by the derivative of the inside. So if I can see the derivative of the peanut plain as day, then if I recognize that, I know it's just f of g of x. So the ones that I can see the derivative of the peanut really easy. So I see the peanut's 3x. The derivative of that is 3. So if I take the antiderivative of cosine, it would be sine of 3x. Oh, I forgot the plus c. Here, the peanut is cosine x, and I see the derivative of that right there. The antiderivative of e to the power would just be e to the power. And that is what I started with. So sometimes you see the peanut. Now on the next two, I don't see it. The derivative of the peanut is 4x. It is masked with this 16x. The derivative of this would be 2x. I don't see a 2x. I just see an x. So in these two cases, some people can still do it, but the easiest way to do these two is by another process. And it's called U-Substitution. So let's look at how we could use, actually, I'll show those. Actually, I'm going to show those on a piece of paper. Do I have any scratch paper handy? I do not. I'll do it down at the bottom. Okay. This is one of those times where I'd like to redo this. Okay, so that first one was 16x times 2x squared plus 3 cubed dx. For the U-substitution, what we're going to do is we're going to let u be the peanut. Now take the derivative of that. Well, that's 4x dx, technically, just to get a little interesting there. I'm going to solve this for dx. I'm going to do a little substitution here. I'm going to replace 2x squared plus 3 with u. I'm going to replace dx with du over 4x. Now watch what happens. The x and the x cancel. The 4 goes into 16, and it leaves me 4 u cubed du. Well, that I can take the antiderivative of. Super easy. 4u to the third power would give me u to the fourth plus c. Well, that would just be 2x squared plus 3 to the fourth plus c. 2x squared plus 3 to the fourth. go to the next page and I'll be able to do more, show more. Do we see the peanut? Well, it's 3x. Do I see the derivative of that? I do. It's a 3. So it gets kind of sucked back in. And the antiderivative of cosine would be sine. So this would be sine of 3x plus c. The next one. 2x plus 3 is the peanut. The derivative of that is just the 2. Antiderivative of sine would be negative cosine. Done. Ooh. This should have a 3 there. It doesn't. Now thinking back, what could I do? Because if I took the derivative, so I know it would have been a sine to get a cosine of 3x plus 2. But if I took the derivative of that, the derivative would be of sine of 3x plus 2 is 3 times cosine of 3x plus 2. But I don't have the 3 there, right? So what would make it go away? Well, if I put a 1/3 out in front, that would make it go away. Aha. On this one, I'm going to move the 5 to the front. Now the antiderivative of e to the 3x would be e to the 3x. It should have had a 3 there, but it didn't, so I'm going to put a 1/3 instead. So that's 5/3 e to the 3x. So think to yourself, if I took the derivative of this, I'd have 5/3 e to the 3x times 3. Check. Now the next ones I'm going to do the U-substitution on. And let's look at that more detailed on page 571, and then I'll go back to this. So there's more detailed notes on that U-substitution. The inner function is always going to be my U, my inner function, my peanut. So on this one, it's 2x minus 1. The derivative of that is 2. Oh, this one's actually a harder one. We'll come back to this one. Oh, I'm sorry. Hold on. Pause that. These are the easier ones. Okay, so sorry about that. One of those mornings. X squared plus 5. du is going to be 2x dx. So du divided by 2x is dx. Now let's rewrite this. I'm going to rewrite that as to the 1/3 power, but I'm going to replace x squared plus 5 with u. And instead of dx, I'm going to write du over 2x. Now the 2x's cancel. So I'm just taking the integral of u to the 1/3 du. Easy. Add 1 to the exponent and divide by the new exponent. So u to the, if I add 1, that would be 4/3. If I divide by 4/3, That's the same as multiplying by 3/4. Now I'll just plug back in what U was. And excuse the bad English on this lesson. We're not talking about U-Y-O-U. We're talking about U, the letter U. But it does get into some interesting things because you have to be careful and pick the right U. It's very important to pick the right U, and that gets almost transcendental. To be the right U, pick the right U. So the right U should be like what's in parentheses or what's under the radical. When you have a fraction, your U will be the denominator. We're going to take the derivative. So that would be du divided by, this is technically like that, 2x plus 2. I'll come back over here. Now I've got the integral of 2x plus 2 over u times du over 2x plus 2. These cancel. So now I have 1 over u du. That gives me the natural log of u plus c. So this would be the natural log of u was x squared plus u is, u was, bad English, x squared plus 2x plus c. What would u be here? X squared plus 2. So du is going to be 2x dx. So du over 2x equals dx. So I'm going to end up with 3x. I'm going to rewrite that to the 1/2 power. That's going to be u to the 1/2. Instead of dx, I'm going to write du over 2x. So in this one, the x's will cancel, but the 2 won't. So I end up with 3/2 u to the 1/2 du. Add 1 to the exponent, divide by the new exponent, so that would make that u to the 3/2. Ooh, if I divide by 3/2, that's going to cancel that out. That's pretty nice. Plus c. So that's going to end up being x squared plus 2 to the 3/2 plus c. U. Now, not only is this in the denominator, but it's under the square root, so we're going to pick u to be 2x squared plus 3. Du would be 4x. So du divided by 4x equals dx. So I would have 3, let's rewrite it, that'd be 3x u to the negative 1/2 times du over 4x. The x's would cancel, and I'm left with 3/4 u to the negative 1/2 du. When I add 1 to the exponent, that's going to give me 3/2. Well, it's not going to cancel. Oh, that's going to give me positive 1/2. That's not going to cancel out like that other one did. So, whoops. So I have 3/4 u to the 1/2. If I divide by 1/2, that's the same as multiplying by 2. So that's going to make that be 3/2 square root of 2x squared plus 3 plus c. Because the 2 and the 4 can reduce. Alright, I'm going to go back to 571. I apologize for that earlier. I realized that this one was a little bit harder, because when I looked at this one and we had the 2x minus 1, when we took the derivative of it, it was a 2, and there's no 2 anywhere in there. There's actually an x in there. So this one is like really weird. So u is going to be 2x minus 1. du would be 2 dx. We're going to solve for dx. And when I have, so I've got the integral, when I plug that back in, I'd have u to the third, and then dx, that would be du divided by 2. But this time the x didn't cancel out, right? What we're going to do is we're going to take this and solve for x. We're going to replace that x with something with a u in it. Okay, so I'm going to solve for x. That's going to be u plus 1 equals 2x. Divide by 2. So I get u plus 1 divided by 2 equals x. Okay, so I'm going to go back over here. Now I'm going to replace x with u plus 1 divided by 2 times u cubed du divided by 2. Okay, so I've got divided by 2 and divided by 2. That's like divided by 4. I'm going to pull out a 1/4 for a second. And I can factor that out. I can pull that out. And I have u plus 1 times u cubed du. I'm going to distribute the u cubed and get u to the 4th plus u cubed. This I can take the antiderivative of. Now it's going to have a 1/4 out to the front. The antiderivative of u to the 4th would be 1/5 u to the 5th. Then this would be 1/4 u to the 4th. And then I'd have a plus c at the end. So this would be 1/20th u to the 5th plus 1/16th u to the 4th plus c. Now let's go back and plug in what u was, what u is, what, yeah, okay. I don't know which word to use there. Let's do one more of the hard ones. Okay, what would be u? U would be the innermost function. That would be x plus 4. So du would be 1 dx. That one's awesome. All right, I'm going to rewrite and solve for x. So u equals x plus 4. So u minus 4 equals x. Now, let's rewrite this integral. Instead of x in the top, it's going to be replaced with u minus 4 plus 1. Now the bottom would be the square root of u. And this is just going to be a du. I need to rewrite this in more of a polynomial type. So I'm going to distribute the top. That would be 2u minus 8 plus 1, that'd be minus 7. And this would really be a u to the negative 1/2 du. Then I'm going to distribute here. Now remember, this is going to be a u to the 1. When I distribute here, we add the exponents, so that would be 1 plus a negative 1/2 would be u to the positive 1/2 minus 7 u to the negative 1/2. Now I can do the antiderivative. Add 1 to the exponent. Divide by 3/2. That's the same as multiplying by 2/3. Add 1 to the exponent. Divide by 1/2. That's the same as multiplying by 2. So this is going to be 4/3. I'm going to go ahead and replace u with x plus 4. Go back to where we started. Then this would be a 14. Plus c.